Think about a multi-layer switch. This switch can do a lot when it comes to access control lists. We can have on the layer 3 ports VACLs, or router access control lists. But what we want to explore in this particular nugget is access control lists applied to a layer 2 switch port. We call these PACLs, or port access control lists. And then how about if we take an ACL and apply it to an entire VLAN? Those are called VACLs, or VLAN-based access control lists. Some literature will also refer to them as Vlan Access Maps, and we'll see exactly why that is in this particular nugget. So we have an access control list, we place it on a layer 2 switch port, and we are dealing with a port access control list. That's the terminology. What types of ACLs are supported on the layer 2 switch port on a Catalyst switch? Well, we can have a standard IP, we could have an extended IP ACL, or we could have a MAC extended access control list. You might wonder if you're allowed to do like one of each, and the answer is yes, you can absolutely do that. So we could go in and we could do like on ingress an extended IP, and then we could also do on ingress a MAC extended access control list. But only one of those types per interface per direction, as you might guess. If you were to add another MAC extended in the same direction, it would overwrite the one that is existing on that particular port in the particular direction. So great news for you Cisco viral lovers out there. The latest version supports these port access control lists, so we can experiment with them in the emulator. Here I have a topology, R1 connected to switch 1, trunked over to switch 2, then connected to R2. We have VLAN 100 running here between these devices. So let me go to R1 and let me ensure that I can ping R2 at 10, 10, 10, 2 across the switches. And we see that works perfectly. Let's also check out the MAC address on the R1 device. So I'll do show interface gigabit 0/1, and we see the MAC address on this particular device is, let's find it, it is ending in 6069. All right, well, let's slide over to the switch now. If we look on this switch 2, and we look at the MAC address table, we see we are learning that MAC address, of course, of R1 on the gigabit 0/1 interface. This is the interface that trunks over to switch 1. So let's have some fun blocking this particular host based on MAC address here in the topology. We'll go in and we'll do MAC access list extended, and we'll say PACL_L2. We'll then deny the host at this specific MAC address. This is the source address. So I'll copy and paste that in, and we'll say going to anywhere. We need to permit, of course, any other layer 2 traffic here. And now we'll exit this extended MAC access list, and we'll go to the gigabit 0/1 interface, and we'll say MAC access group PACL_L2. And this can only be done ingress, this particular access control list. So we'll do it ingress on that interface. We will end the configuration, and now we will go to R1 and try that ping again. So here we are on R1. We retry that ping, and it does not look like that ping is successful now. Think of how tricky this would be to catch in a troubleshooting scenario. Yeah, you would look at the configuration of R1, you would look at the configuration of R2, and everything looks absolutely perfect. If you look at the basic layer 2 configurations on the switches, you might not catch that we are filtering here based on layer 2 MAC address. So we really need verification, though, that it was the switches configuration that did the job here. And that's easy to verify. We can do a show access list on the switch. We see that there is our extended MAC access list named PACL_L2, and that our deny entry does have the 5 matches for those 5 ping attempts, and we can see we're matching all kinds of incoming layer 2 traffic from switch 1. And now we're ready to look at VLAN access control lists, or Vlan Access Maps. A lot of people love to call them Vlan Access Maps because that's the syntax we use to create them. And as you can see, they follow the logic of route maps. These are great because they'll apply to all ports of a particular VLAN, including any future ports that you might be adding to a particular VLAN. Let's make sure we can construct these and test these at the command line. So we slide over to rental equipment, thanks to gigavelocity.com. Thank you so much, Gigavelocity. And of course, we're making this adjustment because VLAN access maps are indeed coming to viral, but as of the very moment of this recording, they haven't made it there yet. So here on R3, we're going to make sure that we can telnet to R1, for example. So here we go, telnet 10, 10, 10, 1. And we see we can telnet into R1 just fine. Well, let's experiment with our VLAN access control lists, and let's kill telnet for VLAN 100. I know what you're thinking. You want to kill telnet, period. Nope. For our purposes, we'll pick on just a VLAN to take advantage of this functionality. So we go over to switch 3 in this example, and the first thing that we do is we create an access list, an extended access list. I'll name it ACL_telnet. And what you always do is you do a permit. Why you're doing always a permit, even though we subsequently are going to deny the traffic, is the ACL is just for identifying the traffic. So we'll say, oh, any telnet traffic in our access list. There we go. Next, we'll construct our VLAN access map. Think of a route map and you'll be great. It's similar structure and logic. So I say VLAN access map. I'll name it VACL_telnet, and we give a sequence number. And what we want to do is match. There are 2 important things we can match on, as we discussed earlier, IP and MAC-based matching. So we'll match on IP address, and it's of course ACL_telnet. Next, we specify the action we want to drop that traffic. Now, if you're thinking in terms of route maps, you realize that we have to do another statement. I'll number it 20, and we have to do an action of forward. This is, of course, overriding the implicit deny that would end this structure, causing us to drop all of our IP traffic forms in the infrastructure. That would be a bad thing. Think about doing this at the MAC level. You would end up stopping things like ARP from functioning. So we have to remember the logic of route maps when we're working here. But all this hard work I did is doing nothing because we haven't applied it to anything. So we'll say VLan Filter. My filter is called VACL_telnet, and the VLAN list that we're applying this to is 100. So we look at our topology and we realize we have this filter in place on switch 3. It should definitely prevent the telnet that we just did a moment ago, right? That was on R3, telnetting to R1. This better not work now. And it doesn't. It does not work now. And it just struck me that I consistently change the color scheme of the consoles, and that's because, of course, different students campaign for different color schemes. My favorite has always been the green on black, and it's because it looks like I'm working on something really, really important. All right, well, anyways, this is not going to work. Now, a question comes in here. What about telnetting from R1 to R5? After all, switch 1 doesn't possess the Vlan Access Map or Vlan Access Control List configuration. So let's see what's going to happen there. I'm going to telnet to 10.10.10.5. Ooh, and it's going to work just fine. So clearly, we need to take the configuration from switch 3, and we need to replicate that on all of the switches participating in VLAN 100 in order to make the VLAN access map logic apply to every potential port participating in VLAN 100, which is our goal. Notice this still gives us scalability as we add ports to VLAN 100 on the different devices. So in this important nugget, we took a look at the ways in which we can manipulate data plane traffic on our multi-layer catalyst switches. I did create a post for you summarizing these many options, and that is available at ajsnetworking.com. If you were to search on PACL, for example, you would have your document. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.